Good afternoon, students. In this session, we shall discuss about distillery industry, how the alcohol is manufactured in distillery units, as well as what are the sources of wastewater, its characteristics, its effects when it's discharged into that of the stream, and finally the treatment of this distillery wastewater. We'll discuss one by one. So this is the basic manufacturing process in the distillery unit. As we know that from the sugar industry, the byproduct what we got is molasses, and this is a very important raw material for the production of alcohol in case of distillery industry. So this molasses first it will be get weighed and it will be get diluted, and along with this molasses yeast will also be added, and it will be subjected to fermentation, and once it is get fermented that alcohol and solid materials will be get formed, and then it will be sent to the clarifier where the solid materials will be get retained while the pure alcohol will be taken off. So then it will be subjected to analyzer column, as well as it will be subjected to degasification and rectification, so that your final alcohol will be get resulted. So this or the raw spent wastewater that is coming from this distillers is a large amount of wastewater, and this distillery industry is one of the industry which is living which will be promoting a large amount of wastewater. So this is various other columns where you will be able to get the range of products from this distillery units. You will see this. So these are the products which could be manufactured from this distilleries. One is the industrial alcohols, another one is rectified spirit, silent spirit, absolute alcohol, and beverage alcohol. But when you see in all these products, the common thing is the process what is used for this manufacture is only fermentation process along with it of the yeast, where they use carbohydrate as a raw materials. As well as this all the final products they contain ethyl alcohol in different proportions. This is a manufacturing process what we already see in the tabulation. See here, this beverage alcohol, this is a manufacturing process of a beverage alcohol, where this beverage alcohol is manufactured from different grains, malted barley and molasses. So these are the raw materials that is used for the manufacture of beverage alcohol. As we all know that the molasses is a byproduct that is coming from that of the sugar industry. This is a very important principal raw material for the production of alcohol. So the what is the manufacturing processes? The first one is your preparation of your mash, that is the first step, and then second one is preparation of your molasses, so that the final process will be a combination of your and this molasses along with it of the yeast. So what is the preparation of mass? How does it been done is, first one is the green malt has been prepared with the help of your different grains as well as malted barley. So that malt is first prepared. Then it has been the preparation of cooked slurries of the grains is also done, and after that these two will be get mixed together, that is green malt as well as the cooked slurries of the grains gets mixed together, which will be followed by pH adjustment as well as nutrient supplementation. So this is the principal raw material for the manufacture of your alcohol. So second raw material is your molasses, as we already saw. So this molasses also as such we cannot use it in this process. We have to do certain preparations. So in this case, this molasses first it will be get diluted by water to a sugar content of about 15 percentage. And then this molasses it should also be maintained with a pH range of 4 to 4.5, so that it will be propagating the other bacterial activity, and finally it will be added with a nutrient also, so that it will be given with a proper nutrient supplementation. So in the manufacturing process, the yeast what is get prepared, it will be diluted with it of your molasses along with it of the raw materials, and it will be subjected to fermentation under controlled conditions. So in this case, it will be get fermented where your alcohol as well as solid material will be get resulted. So the alcohol will be sent to the overhead tank, while the solid materials it will be get removed off in your filtrates. Then this will be further degasified where the alcohol will be stripped and it will be get redistilled and it will be stored in vats. So in this case, at this stage, gin is able to produce. But if you want whiskey, this whiskey manufacturing, it requires a longer period of time because whiskey always requires aging process in the charred oak wood barrels. So these are the sources of wastewater that is arising from this distillery units. One is the spent wash, as we already saw in the flow chart. So this is a major amount of wastewater that is coming from this because it's a high volume of wastewater is being produced from this distillery unit. And apart from that, from the fermentation process, we'll be getting the wastewater and condensate what is used in this along with the boiler and cooling towers. That wastewaters will also be there and floor washers, cooling waters and yeast sludge. So these are the normal wastewater that is coming from that of your distillery process. These are the characteristics of your composite combined waste spent wash as well as yeast sludge from the different Indian distilleries. You could see a variety of parameters here like starting from pH, COD, BOD, solids, alkalinity, color, dissolved oxygen, etc. Since this distillery unit is once again the organic industry, you could see that COD and BOD is there, but compared to the other industries in the distillery units, you will be able to see very high CODs in the range of 70,000 to highest of 1,51,000. And similarly, BOD is also very high up to the range of 80,000. Similarly, total solids is also high. So that is why this distillery industry is said to be one of the highest polluting industry. And one more is the safe disposal of this distillery into that of your sewer. It will be affecting that entire sewage process also if it is not properly get disposed of. So that disposal problem is also very important here. And this values are the typical values that is given for the distilleries, but it varies from industry to industry depending upon the manufacturing process as well as water characteristics and other ingredients, all those things. However, this shows you the typical values where you could see that the temperature of the spent was is also very high, 90 to 95 degrees centigrade. This shows that we cannot leave this wastewater as such directly into the stream because of this high temperature. It will be affecting the aquatic life inside the stream as well as it cannot be sent to the sewer courses also. So that is the main drawback of your distillery industry. So as we already see, this distillery waste, it has been, the distillery is using molasses, so that's a byproduct from that of the sugar industry for the production of alcohol by fermentation as well as distillation process. And we could see that we have a highly organic as well as a colored wastewater is will be coming out from this distillery industries. And this is considered as one of the most polluting industries. When you could see here, total waste volume will be 60 to 100 liters of waste per liter of alcohol produced. That means 1 liter of alcohol will be able to produce 60 to 100 liters of wastewater. So you could see how much amount of wastewater is being discharged from this distillery units. So the waste streams that comprises the spent wash, which is the main source of the wastewater, and apart from that it will be having spent lees as well as yeast sludge, and normally the spent lees will be combined with that of the spent wash itself. So in the production of alcohol from molasses, we could say that from 3 to 10 kg of molasses are used for producing 1 liter of alcohol, and for each 1 liter of alcohol you could see 10 to 15 liters of spent wash is produced. That is the highest amount of wastewater that has been generated in this industry. And the distillery spent was what has been produced, as we already saw the temperature is also high. So it is very hot, it's highly colored and it is acidic. Apart from containing high percentage of dissolved inorganic and organic matters, we know that organic matter is the main source of biochemical oxygen demand as well as the polluting nature of the waste. And the spent wash, it also contains dissolved salts and it also has a persistent dark brown color. So that is the main drawback here. And you could see in this tabulation that pH is also in the range of 4 to 4.5 or 3.5, 3.65, 4.8. This shows that a very high acidic wastewater is being generated from this distillery industries. and you could see that there is probably no dissolved oxygen in that case of a spent wash. That means there is no, oxygen which is useful for your aquatic life if it is get disposed of. So, what is the effects on receiving stream when it has been discharged into that of the this wastewater or discharged into that of the stream? Normally, this wastewater is non-toxic to aquatic life in the receiving stream, but what happens is it will be depleting the dissolved oxygen because of the high amount of the biological matters, that is your BOD substances here, and since it depletes the dissolved oxygen, automatically there is, if there is no oxygen, it will be lead to anaerobic condition. So this anaerobic condition, as we know, that it will be leading to malodouring situation, as well as growth of sewage fungi is also be possible in case of a stream. And since it's having very high BOD content, we cannot go for using with aerobic biological treatment because it will be very highly expensive and it could not be treated with a high amount of BOD, and therefore it is not suitable for discharging into municipal sewage treatment plant, where we will be using the some of the aerobic treatment methods also. So only way is by giving proper treatment, and after that it can be sent to that of any of the other disposal methods. So this is a treatment what is given in the large distillery complex. So you could see that different waste is being originated here. So you can have either distillery waste, or if it is a brewing industry, you will be having brew house waste. If it is a malting industry, it will be having a malt house waste, as well as storage and bottling and floor washings will be there. And food canning division, if it's there, that wastewater will be there. And if it is BOD washings or domestic wash, that will be taken separately there to the polishing pond, and then finally it will be taken to the of the effluent. So in case of this distillery waste, as we said, it's very high in BOD. You could see here 19,000, but as high as nearly 60,000 also will be able to get from that flowchart. You will be able to see very high BOD is also there. So it is first sent to anaerobic lagoon, that is two-stage anaerobic lagoon followed by two-stage aerated lagoon. So that is proved to be the cheapest treatment technology for converting this BOD to that of the less organic substances. Then it will be taken to that of the polishing ponds. While the other brew house waste and malt house waste, it is subjected only to the two-stage aerated lagoons, and then it is subjected to polishing ponds. So this is a treatment that is given to that of your distillery waste. So you could see in case of distillery waste, you will be getting BOD of 19,000 milligram per liter, while the brew house waste is only 2,800, and that of your malt house is 800. While the storage, bottling and floor washing is also high, it is having of 4,200 milligram per liter. While the other domestic waste and everything, it has very less milligram per liter, like BOD washings it has 35, and domestic waste it has 400 milligram per liter. Only because of this it is taken directly to that of the polishing ponds, while the other high BOD it is taken to aerated lagoons, and very high BOD of 19,000 is taken to two-stage anaerobic lagoon as well as two-stage aerated lagoon. As I already said, anaerobic lagoon, aerated lagoon is it's not possible with that of the high BOD because it requires large amount of aeration, which makes it uneconomical. So the methods of treatment from the flowchart, you could see that this is more amenable to that of the biological treatment, both anaerobic as well as aerobic treatment. So in case of anaerobic digestion, about 90% of BOD reduction we can expect from this. And if we go with anaerobic digestion, even methane gas recovery is also possible as a byproduct from this process. If we are going for anaerobic lagooning, this is a very cheapest one, but only thing is we should have a sufficient land for this lagooning process, and that research shows that even 95% biochemical oxygen demand can be done in this anaerobic lagooning. Apart from that, we will be going for aerobic process like trickling filters and activator sledge process, but extended aeration can also be used for this process. But however, this is found to be higher costlier unless otherwise we have with that of the anaerobic treatment process. So other than this, we can have your other treatment methods here, like your physical treatment methods like sedimentation, screening, aeration, filtration as well as flotation. and chemical methods like chlorination, coagulation, adsorption and ionization. So these are also possible. Normally in case of a distillation, you will be having your initial preliminary treatments that will be normally required, and apart from that you will be having your biological treatment methods, that is the main treatment methods to reduce this biochemical oxidation, that is a BOD, organic matter, in that of your distillery wastewater. But normally when you see in any industry, the main thing is we have to concern in the four R's, as we know that it is a reduction, reuse as well as recycle and recovery, so that the possible wastewater will be get utilized, as well as the waste will be get utilized for the inside the industry or with the other processes. So this is the main important byproduct which could be get recovered from this distillery units. That's we know that yeast sludge is a waste that has been coming from this distillery. So this yeast sludge can be used as animal feed. Normally what they do is it will be subjected to evaporation as well as drying, so that it will be converted into dried distillers solubles, that is DDS, which could be used as animal feed. Apart from this, this DDS can be also incinerated at a temperature of 700 degrees centigrade, so that it will produce an ash which will be rich in potassium salts. That's why the potassium fertilizers can also be able to produce from this distillates. Okay, so this dried distiller solubles, it has two purposes. One is it can be used as animal feed, and other one it can be used as production of potassium fertilizer. So further, this ash what is coming from this incineration of your dried distilled solubles, it will be subjected to leaching with water as well as filtration and acidification with sulfuric acid, and further it will also be subjected to vacuum evaporation and crystallization, where your final potassium chloride and sulfate can be received. So from the ash is also being turned, instead of using the ash with potassium salts directly as fertilizer, this ash can be subjected to a series of operations like, as we said, leaching, acidification, concentration and crystallization, where you could get a pure potassium chloride as well as sulfate, which can be used as a direct fertilizer. So we could see in this the byproduct recovery, nearly 3.85 tons of potash can be recovered from the 320 meter cube of spent waste. That means you could see a high volume of potash can be recovered, and apart from this you can go for 5.75 tons of potassium chloride and 1.27 tons of potassium sulfate from this spent wash. So this shows that it's a byproduct recovery is really valuable in case of your distillery units. Apart from this, the distillery wastewater that from the yeast sludge yeast can also be used for the other industries, also for the production of your medicines, all those things you can go for using it up. And apart from this, this yeast can also be used as animal feed, that is your cattle feed, if it is properly dried as well as processed. So this is an important byproduct recovery, so that the final waste that is coming from the distillery in terms of your organic matter will be get reduced, and so that it will be easily can be treated and disposed of. Okay guys, in this session we have seen about the distillery industries, its treatment as well as the wastewater and characteristics. From that we could see that a very high BOD is being resulted from this distillery. Not only BOD, the other organic matters has been resulted, and we could see what is the effective recovery process also we have seen in this. So in the next session we will be seeing some other industries. Thank you guys.